Hello everyone, today we're going to look at the greatest common factor. The greatest common factor, also known as the GCF, is the largest factor that all terms have in common, hence the name. So we've been finding the GCF of numbers for quite a while, but let's just do a little review of this. So find the GCF between the given numbers, 4 and 3. So in order to find the GCF, what we're going to do is we're going to factor both of our numbers. So 4 is 2 times 2, and 3 is just 3. So what is the greatest one of these that they have in common? Well, really that's a factor that I didn't show, which is 1. So every number has a factor of 1, and that happens to be the only factor 4 and 3 have in common, so therefore it must be the greatest common factor as well. How about 6 and 15? So if I factor 6, I have 2 times 3. And if I factor 15, I have 3 times 5. And again, we'll always have the 1. So what they have in common, besides the 1, is the 3. So 3 times 1, but again, we don't really need the 1 unless it's the only thing they have in common. So the GCF here is 3. How about 24 and 40? So 24, if I start to factor it, we can always try our factor trees, if we remember back in, say, elementary school or middle school. So I'll just keep factoring until I can't factor anymore. So 24 is 2 times 2 times 2 times 3. 40, can do 4 and 10. 4 is 2 and 2. 10 is 2 and 5. So what they have in common are 3 2's. And what are 3 2's? 8. How about 150 and 45? Whoops. Let's try that again. 150. Well, I know that's 15 and 10. I know 15 is 3 and 5. And I know 10 is 2 and 5. So the factors of 150 are 2, 3, 5, 5. And then 45, well, I know that's 9 and 5. And I know 9 is 3 and 3. So then I look at it and say, what do they have in common? They both have a 3 and a 5 in common. And what is 3 times 5? 15. So for the last pair, 70, that's 7 and 10. 10 is 2 and 5. 28, that's 4 and 7. And 4 is 2 and 2. So it really helps to know your multiplication and your times tables and how to, and factors of numbers in order to do this quickly. But don't forget, you do have a calculator at this point, so you can use your calculator. So what do they have in common? They both have a 7, and they both have a 2. And what's 7 times 2? 14. The real question is, how do we do this with variables? So what we want to think about are the factors of something like x to the n. So the factors of x to the n are 1, x, x squared, x cubed, x fourth, all the way up to x to the n, assuming, of course, that n is a positive integer. So if I want the GCF of x cubed and x to the fifth, I look at their factors and see which is the greatest. So the factors of x cubed are 1x, x squared, and x cubed. The factors of x to the fifth, 1x, x squared, x cubed, x to the fourth, x to the fifth. The largest that they have in common is x cubed. And in general, the GCF is going to be the smallest exponent. That only works, though, if the bases are the same, right? If I had x squared and y cubed, their GCF would be 1, because the x squared doesn't have any factors of a y, and y cubed doesn't have any factors of an x. So the bases have to be the same. But assuming they are the same base, then it's just the smallest exponent. So between 3 and 5, 3 is smaller. So now let's find the GCF between the given terms. 20x cubed y squared and 15x squared y to the 5th. So if I ignore the coefficients for a second, and I look at the x's, I have x cubed and x squared. The smaller exponent is x squared. Then I have, for the y's, y squared, y to the 5th, and 2 is smaller than 5. So variable-wise, I have x squared and y squared. Coefficient-wise, 20 is 4 times 5. 4 is 2 times 2. 15 is 3 times 5. So what they have in common is a 5. So the GCF is going to be 5x squared y squared. What about this guy? So now we've got 3 of them. So again, let's look at the variables. So I have a squared in the first term, a in the second, a to the 4th in the third. So the lowest exponent is a to the 1, which is in the second term. For b's, I have b cubed, b to the 5th, b cubed. The smallest is b cubed. And then c's, I have a c, I don't have a c, and I have a c to the 8th. Since I don't have a c in my middle term, it can't be a common factor. So for the variables, it's just ab cubed. And then we look at the coefficients. 40 is 4 and 10. 4 is 2 and 2. 10 is 2 and 5. 28, 4 and 7. And again, 4 is 2 and 2. 20, 4 and 5. 4 is 2 and 2. And if I notice, this 4 or the 2 2's, either case, is what they have in common. So the GCF is going to be 4ab cubed. Let's try another one. Again, we have 3 terms, 8xyz cubed, 16x squared y squared z cubed, and 32xy to the 4th z. So in this one, if I look at my coefficients, hopefully I can tell right away that the GCF is going to be 8. Each of them are divisible by 8, and the first term, obviously, it can't have a higher factor than 8. So then we move on to our x's. We have x, x squared, and x. The lowest is x. For y's, we have y, y squared, y to the 4th. The lowest is y. And for z's, we have z cubed, z. The lowest is z. So our GCF should be 8xyz. And our fourth one, 50a squared b cubed c to the 4th, 400 ab squared c squared, and 140 a squared b. So again, we'll start with the variables because they're actually the easiest. So for a's, we have a squared, a squared. So the lowest exponent is a. For b, we have b cubed, b squared, b. Lowest exponent is b. And again, our third term doesn't have a c, so the c can't be part of the greatest common factor. So variable-wise, it's ab. And now we'll look at our coefficients. So 50 is 5 and 10, and 10 is 5 and 2. 400 is 40 and 10. 10 is still 2 and 5. 40 is 4 and 10. We have another 2, 5. And we have another 2, 2 from the 4. So there's lots of factors in 400. 140 is 14 and 10. 10 is 2 and 5. 14, 2 and 7. So for the 3 of them, we have at least a 2 and a 5. And now 50 and 400 have another 5 in common. 400 and 140 have another 2 in common. But 50 and 140 don't have anything else in common. So in common to all of them are just the 2 and the 5, which gives us 10. So 10AB is our GCF. And let's move on to our last one. 12x to the 4th, y to the 8th, z squared. 16x cubed, y cubed, z to the 9th. 10x cubed, y cubed, z cubed. Okay. So for the x's, we have x to the 4th, x cubed, x cubed. The lowest is x cubed. Y's, we have y to the 8th, y cubed, y cubed. The lowest is y cubed. And then z's, we have z squared, z to the 9th, z cubed. The lowest is z squared. And then we move on to the coefficients. 12 is 4 and 3. 4 is 2 and 2. 16 is 4 and 4. Each of those 4s becomes 2 and 2. And then 10 is 2 and 5. So for between all 3 of them, we have a 2 in common. So the GCF is 2x cubed, y cubed, z squared. Okay. So again, it's really helpful if you know your multiplication, if you know your factors of integers, and then for variables, it's just the lowest exponent. Okay, so practice, and let me know if you have any questions. Thanks.